Okay, section 9.3. There's three things you're going to do. You're going to be finding two measures of variation. One is this coefficient determination, which is just r squared. Okay, so you guys have found the correlation coefficient, r. If they just give you r, just square it. You get the coefficient of determination. Okay, the other thing will be this standard error of estimate. Really, when you find this, it's really to use in a formula. Okay, now the r squared you can find using ln-reg, right? Go stat, calculate ln-reg, okay? And standard error estimate, okay, you can use your calculator to find that too, okay? You go to stat, test, ln-reg t interval, okay? And when you do this, okay, it looks like you have to put in the confidence level. Well, it can be anything. If they don't give you anything, you don't need one. You can have it anything you want, and you can run get the interval, okay, which is not the interval we need later when we get into the finding an interval. But when you go on there, S sub e, the standard error of estimate, it will just show up as S. The other thing you're going to find is a prediction interval, okay? And they have this in the book. So what you do is you need to find y hat, and you need to find e, because what you'll do is you'll add e to y hat and subtract it from y hat to get your lower and upper bounds of your interval. Okay, what is y hat? It's just a point estimate. And what's it from? It's from y equals mx plus b, that ln-reg regression equation. Okay. Okay, we'll do that in a little bit. And then E, margin of error, you get from, and this is the fun part, you get that from this formula, which the calculator will not do for you. You have to do it. Okay. So r squared you can find on your calculator, or just by squaring r. S sub e you can find on your calculator, but e you got to use this formula. So to go run through all this, we're going to use examples number 2 and 3 on page 516 and 518. Okay, so here's what you can do, and you could stop the video and enter all these numbers in list 1 and list 2. They've been using these numbers all the way through chapter 9. This is gross domestic product in trillions of dollars, and this is CO2 emissions in millions of metric tons. And they're looking for, some correlation between how much money a country makes and has and the pollution, CO2 emissions. Now, after you've entered that data, you can go to ln-reg and find r squared directly. Okay, so what is this r squared coefficient of determination? What does it tell us? Okay, here's how they predict it. They say, okay, 0.78, 78% of the variation or differences in carbon dioxide emissions can be explained by the variation in gross domestic product. Okay, now if you take 100 minus 78, you get 22. That's 22%. At 20%, 2% of the variation, we don't know why that is. Next, we're going to find that prediction interval. Okay, to do that, we're going to put the data on the calculator. Well, I've already done that. You might have already done that. Okay, find the numbers we need, okay, which is for that formula. Find the prediction interval by adding and subtracting the margin of error from the point estimate, and then we'll interpret the interval. And so here's basically, in a nutshell, the question. Find a 95% prediction interval when the gross domestic product is $3.5 trillion. Okay, so here's everything we need. Okay, you might go, oh my word, but a lot of that the calculator can find for us. Okay, first, we'll see how you find y hat. Well, you get it by plugging in, okay, 3.5 trillion in for x into the equation you would get off ln-reg, right? So you put your data in, you go to linreg, you go to stat calculate linreg, you come up with this linear regression line. You put in 3.5 trillion. This is your x naught. Okay, you're doing prediction interval for this amount of money. They give this to you. Okay, when we calculate that, we get about this many million metric tons. Okay, so there's y hat. Next, you need critical value, right? T sub c. Okay, you go to inverse t. Area, it's 95% confidence level, right? Don't put in 95.95. This is a two-tail situation. Okay, so I take the 0.05, cut it in half, put in 0.025. Degrees of freedom, you subtract 2 from n, you get 8. You get this, but you always use a positive t. Okay, third, n equals 10. That's just how many, okay, numbers you have. Okay, fourth, x bar, mean, sum of your x's is sum of your x squareds. All three of these numbers you can get off linear regression, where you find your linear regression line. Okay, next, standard error of estimate. Okay, it's about 138.255. Then reg t interval, right? Remember, your confidence level can be anything. And lastly, the x naught, 3.5, right? That's given to you. Okay, now how does the formula work? So I've scribbled all over my book. Here's the formula. Now, you have to make sure, one thing I notice is they always round, if the numbers go more than 3 decimal places, they round to 3 decimal places. You have to use fractions, please. Please use fractions. And then here, look at where the parentheses are. Okay? If anything is messed up in here, you obviously will get the wrong answer. So you got to make sure everything's put in exactly as it needs to. Now, they come up with E, the margin of error, being about 350, 349.424. Okay? So what they do is they take that y hat, right, that point estimate, and they add and subtract this. Okay, so they subtract it, they add it, there's their interval right there. So what is their interpretation? They say you can be 95% confident that when the gross domestic product is 3.5 trillion, the carbon dioxide emissions will be between that and that many million metric